Okay, this video is going to be about absolute value inequalities. Absolute value inequalities. You're going to have two types of inequalities. You're going to have less than, and you're going to have greater than. And these could also be less than or equal to, greater than or equal to, but they'll work the same way. So less than, equal to, greater than or equal to. Here's how they work. If the absolute value of something is less than a number, it'll mean, okay, so here, if this is 0, if my absolute value, let's say, is smaller than 3, absolute value of my number has to be less than 3. Well, that means if this is 0, then my point, my coordinate can be no more than 3 units away. So it could go anywhere from -3 to +3. And it would be somewhere in between these two numbers. So anytime you have a less than, it's going to mean you're keeping it close to the center of your number line. When you have a greater than, it means it's going to be more than so many units away. So if I said the absolute value of x is greater than 2, it means that if I've got a number line and zeros here in the middle, and if I'm going to be more than 2 away, then I would start from 2 and go to infinity this way, or from -2 and go to infinity this way, negative infinity this way, so that I'm more than 2 away. So that's kind of how absolute value is going to work. So let me go through a few of the examples that they give you in your book and kind of see. They want us to graph it and write our answer in interval notation. So that's something that we need to go back over, how to write our answers in interval notation. And we'll talk about that as we go through some problems. So let's take a look. Let's say I did problem number 34. 34 says the absolute value of x is less than or equal to 4.5. So that means that my number is going to be between -4.5 and +4.5. Whenever it's a less than, it's between two values. And the way that you graph that is at -4.5. I'm going to put a bracket because it's less than or equal to, so it can equal that number. And at +4.5, I'm going to put a bracket because it can equal that number. And then I'm going to shade between them. In interval notation, that's from bracket -4.5 to +4.5, both with brackets. Let's try another absolute value problem that's a less than. Hang on just a second. Okay, let's take a look at another less than problem. This is problem 46 in your book, and it says the absolute value of x plus 6 is less than or equal to 10. That means that x plus 6 has to be less than or equal to 10 or greater than or equal to -10. It's going to be between -10 and +10. Whenever you have a less than symbol, you have to put what's inside the absolute value goes between the negative value and the positive value. And then I've got to solve for x. I've got to isolate x. So if you'll notice it says x plus 6. So to get rid of that, I've got to subtract 6. But I'd also have to subtract 6 here and subtract 6 here. So my answer is -16 is less than or equal to x is less than or equal to 4. So what that would look like on a number line is I'd start at -16, I'd go all the way to -4, and I'd put a bracket because it's less than or equal to. I'll do one that's not a bracket here in a second. And I'm going to shade in between them because x is in between them. In interval notation, that would be from -16 to -4. All right, let's take a look at a greater than one so you can compare. In fact, I'm going to go ahead and do it on this screen. I'm going to just draw a little line down the middle. Let's say I were to do problem 48. It's very similar. It's the absolute value of x plus 6, just like 46 was, but this time it's greater than 10. So there's some differences. The absolute value part's the same, but instead of being less than or equal to, it's just greater than, not an equal to. And so that's our difference. So not only are we going to be shading different directions, but we also are not going to have a bracket, we're going to have a parentheses. So here's how you do the greater than one. Because they're going in two different directions, you notice here you're shading between two things, but back over here when I talked about the greater than, they were going to the left and to the right. because of that, you have to write greater than as two separate problems. So you write down x plus 6 is greater than 10, or x plus 6 is less than negative 10. You solve them separately, and then you shade them. You're going to be shading in opposite directions. So subtract 6 from both sides. You get x is greater than 4. And subtract 6 here. You get, I did that wrong here. It was positive 4. It wasn't negative 4. I need to go back over here. This is to 4. Sorry. Um, subtract 6 here. It'd be negative 16. X is less than negative 16. So what I would do on a number line is I would want to put at 4, I'd want a parentheses because it says greater than 4, shade to the right, and then less than negative 16 would be over here, and I'd shade to the left. And in interval notation, that would be from negative infinity to negative 16 with the parentheses, and from 4 to infinity with parentheses as well. Apologize over here for getting a negative 4 down here when I had 4 in my answer. All right, let's take a look at one more. 56. 56 is absolute value of 5 minus 2x is greater than 10. I've got a lot of different things going on here, and you'll see as we go through the problem. But because this is greater than, I'm going to write it as two separate problems. 5 minus 2x is greater than 10, or 5 minus 2x is less than negative 10. Then I've got to solve this. So subtract 5 from both sides. You get negative 2x is greater than 5. Divide by negative 2. When you divide both sides of an inequality by a negative number, you have to reverse this symbol. So this becomes x is less than negative 2.5. Okay, over here I'm going to subtract 5. I get negative 2x is less than negative 15. Divide by negative 2. Negative 2 cancels. Again, I divided by a negative, so that's going to be x is greater than 7.5. So on a number line, I would want to shade negative 2.5. I'm going to put a parentheses again because it's less than and not less than or equal to. So parentheses, shading to the left. And then at 7.5, I'm going to put a parentheses. I'm going to shade to the right. They want me to graph it and write the answer in interval notation. So in interval notation, it's from negative infinity to negative 2.5, and then it's from 7.5 to infinity. Let me do one more greater than one because every one we did was just parentheses. So let me do a greater than one that has a greater than or equal to, just so you know that it's not always parentheses with greater than. It does that every time I record. Problem 54. Problem 54, the absolute value of x minus 7 is greater than or equal to 0.4. So I'm going to write it separately because it's a greater than problem. So x minus 7 is greater than or equal to 0.4, or x minus 7 is less than or equal to negative 0.4. Add 7 to both sides. I get x is greater than or equal to 7.4. Add 7 to both sides here, and I get x is less than or equal to 6.6. So what I would do here is I would graph this at 7.4. I would put a bracket and shade to the right because it's greater than or equal to 7.4. And then at 6.6, I'm going to make a bracket and I'm going to shade less than. X is less than or equal to 6.6. So in interval notation, that would be from negative infinity with a parentheses to 6.6 with a bracket, and then from 7.4 with a bracket to infinity with parentheses. All right, that's inequalities, and that should take us through the end of the chapter. I will start on the review on my next video.